Hello students, my name is Dr. Bimal Srivastava. I am Associate Professor in Department of Applied Sciences Humanities in ABES Engineering College. In our previous discussion, we were discussing how to find particular integral that is called PI of non-homogeneous ordinary differential equation with constant coefficients. So we discussed about several functions like if right-hand side of our equation is of the form fx is equal to e raised to power ax in general, e raised to power ax. Then how to find pi? So some correction in there. In my previous video, I spoke about this is x minus 1 upon something like this. This is not minus. This is basically multiplied. So x multiplied by this quantity. So this is a correction. Now, today we will be discussing how to find pi when our fx is sine ax or cos ax. In more general form, this could be right sine ax plus b oblique cos ax plus b, where a and b are some constants. So we will discuss our discussion with taking fx is equal to sine ax oblique cos ax. Let us consider our equation f dy is equal to fx. So once we find pi, this fd will come in right hand side 1 upon fd into fx. So this could be written as 1 upon fd sine ax oblique cos ax. This can be written as 1 upon fd square sine ax oblique cos ax. So question arises, why we are considering fd square in case of, that is in terms of or in place of, we can say fd. So reason is that here, once we are going to find pi in case of sine or cos, we are only focusing on the term of d square. That means in fd, the terms which is of second degree terms. That is why we are putting is fd square. That is, we are only concentrating on the term in degree 2 in d. So that means how to find pi. So in this case, pi is 1 upon f of minus of a square. That means d square is replaced by minus of a square. So one thing is very important to remember this is of minus of a square rather than minus a square. So students do commit, basically this is a very important line. You have to remember it. In general, what we have find that students in place of d square, they put minus a square, which is wrong. Actually is d square will be replaced of minus of a square. So this is first we do a square and then put the minus. So that is d square will be replaced by f of minus of a square sine ax oblique cos ax. So let us take an example. Suppose we have an equation d square plus d minus 2y is equal to sine x. So for pi, this is our fdi function. So we are taking this fdi in the right hand side. This becomes 1 upon d square plus d minus 2 sine x. So again, we are only focusing on the term of d square. So what we are doing here, if we see our equation, that was 1 upon d square plus d minus 2 into sine x. So the value of a here is 1 and d square is this. So we will only consider the term d square. We will not touch this term of d. So as we have discussed in our previous slide, d square will be replaced with minus of a square. So in our case, this is minus of 1 square. So in this expression, we are replacing d square by minus of 1 square plus d minus 2 sine x. So once we simplify this, this will become 1 upon minus 1 plus d minus 2, that is 1 upon d minus 3 sine x. So we are only focusing on the term of d square, but if we see this here, there is no term of d square. But we can bring a d square term here also. How we will do this? We will rationalize this number, that is we will rationalize this factor. So we will multiply 1 upon d minus 3 by d plus 3 and d plus 3 said we will multiply by d plus 3 and divided by d plus 3. So this is the important step you have to remember. Whenever you will get this type of term, so you have to remember that we have to rationalize it. So once we rationalize it, we will get d plus 3 into this is d minus 3, d plus 3. That means 1 upon d square minus 9. That is a square minus b square. That means a plus b, a minus b into a plus b is equal to a square minus b square. So this is d square minus 9 square. So in this case, we again opt a term of d square. So first of all, we will solve this term in which the denominator is in our d is in our denominator, and then we will solve this term where the d is in the numerator. So again, we will replace this d square by minus of 1 square. That is not minus 1 square, minus of 1 square. So that is 1 upon minus 1 square minus 9. So once we will solve this, we will get minus 10. So this will become minus 1 by 10 d plus 3 sine x. Simplify this, we get minus 1 by 10 d sine x plus 3 sine x. So basically what is d here? D is nothing but d over dx, that is differential operator. So once we applied this differential operator on sine x, the differentiation of sine x is cos x, and this is 3 sine x, it is okay, 3 sine x. So this is our pi. So in this case, our solution will be y is equal to some CF, which we will calculate, and pi. So that means CF plus whatever pi we have got here, this is 1 by 10 cos x plus 3 sine x. So that is our complete solution. Let us take another example. Again, the thing is important to be remembered here is that once we are applying this formula, this is f of d square. The condition is that f of minus a square should not be 0. That means once we are replacing d square by minus of a square, so denominator should not be 0. If it is 0, we will do what we will do. We will see the next example. So suppose again we have fx is equal to sine ax or cos ax, and in this case f of minus a square is equal to 0. Then what to do? The same procedure as we discussed in our exponential case. We multiply this expression by x and differentiate fd. Basically, this is fd. If we see, our equation is pi is equal to 1 upon fd square into fx. So what we do that? We multiply this by x and differentiating this fd square with respect to d once, and then d square replaced by minus of a square. Again, condition is that provided this is not equal to, that is f dash of minus a square is not equal to 0. If this becomes 0, then again we multiply this expression by x square and again differentiate f dash with respect to d again, and then replace d square by minus of a square, and so on so forth. So we will do this until unless our condition is supporting us. That means until unless this denominator is non-zero. Whenever it is 0, we will proceed this again and again. So again, this formula is workable whenever f double dash of minus a square is not equal to 0. Let us take an example. D square plus a square y is equal to sine ax. So again, I am leaving how to find CF. I am just focusing on pi. For pi, we are taking this fd on the right hand side. This become 1 upon d square plus a sine ax. So here fd square is d square plus a square. Once we find f of minus a square, why we are taking minus a square? Since the coefficient of x here is a. So once we are replacing d square by minus of a square, this becomes 0. So once this becomes 0, our previous method will not work. So what we will do, we multiply this, if take equation number 1. So we multiplied this equation by x and differentiating this fd with respect to d. So once we differentiate d square plus a square with respect to d, we get x. First we multiply by x and then differentiation. So we get x into 1 upon 2d sine ax. So what is next? So this is 1 upon d is what? The question is, what is 1 upon d? D stands for d over dx. So 1 upon d basically stands for integral. Integral of function with respect to x, that is dx, f dx. So in this case, it is, if we simplify this, we get x by 2 into 1 by d into sine x. So that means we have to integrate sine x with respect to x once. So basically sine ax, not x, here is ax. So we integrate sine ax with respect to x. So integration of sine x is equal to minus cos ax divided by a. Then we simplify this. So we get pi is equal to minus x upon 2a cos ax. So complete solution y is equal to cf plus pi. Cf, I'm not focusing on this. So my pi part is y is equal to cf. We put the value of pi x upon 2a cos ax. So complete solution is y is equal to cf minus x upon 2a cos ax. This is the complete solution. Let us take another example. D raised to power 4 minus m raised to power 4 y is equal to cos mx. So again, for pi, we are taking this fd in the right hand side. So 1 upon d square minus m4 cos mx. So this d raised to power 4. So now question is that we are only focusing on the term of d square. So if there are any terms in the equation of d4, we can write like d square into d square. If any term of dq is there, we can break it as d square into d. If we have any term of d raised to power 5, we can write it as d square into d. So any terms of d square will be replaced by minus of a square, and the terms which remains will be remain same. And then we will simplify this by some methods which we have discussed earlier and we will discussing here. So now d is raised to power 4. So here fd square is equal to d raised to power 4 minus m raised to power 4. This can be written as d square into d square minus m raised to power 4. And this d square will be replaced of the coefficient of this, that is coefficient of x into in cos x, that is m. So this is minus of m square and minus of m square minus m raised to power 4. So here this becomes, if you see, m raised to power 4 minus m raised to power 4 is equal to 0. So that means in this case, our denominator is becoming 0. So what to do? So again, we will apply the formula. The formula, that means we multiply this by x and differentiate the denominator. So once we differentiate this denominator, this will become cos mx. So here we have two choices to solve further. First is, just as we have discussed, once upon d represent the integral with respect to x, this is dq. So that means we have to integrate cos 3 times, that is cos mx 3 times with respect to x. That is the 1 upon dq cos mx is equal to something like this. Second method is that 1 upon x upon 4 and multiplied by this dq can be written as d square into d into cos mx. So this will become x by 4. Again, this d square is replaced by minus of m square into d into cos mx. So this will become minus x upon 4 m square into 1 upon d cos mx. So now integration of cos mx, as we have discussed earlier, 1 upon d represent the integration. So this will become x 4 m square into the integration of cos mx is sine mx divided by m. So once we solve this, we will get minus x sine mx divided by 4 m cube. So this is our pi. So solution will be cf plus pi. Again, I am not focusing on cf. This is pi is the x sine mx divided by 4 m cube. So that is the solution of our problem. Thank you.